we're still working on deploying our first smart contract to the Osmosis testnet. You've got Osmosis command line set up by now. You've configured it and set up a local wallet, so you're ready to upload. Now it's time to actually go over to the code and build, compile it, and then optimize it, which is a crucial step since we want our code to be as small as possible. Head over to wherever your counter contract is. Now I'm just using a base one. But you should use your extended one that you've built on in the recent exercise. I'm assuming that you've already set up Rust entirely and that you also added this target, a Rust up target add wasm32, so that Rust knows how to compile to wasm. And that's the bytecode that is necessary to upload to many smart contract platforms, including CosmWasm. So assuming you've done that, you can run cargo wasm in order to actually build the wasm from your smart contract. First time, this will take a little bit as Rust has to compile, cargo has to go through and compile all of the necessary dependencies. Now that cargo has built my entire product here, my entire project, I could see in the target folder, which is hidden, all of these various files here, including wasm targets here. There's a release. I've got to really go deep in order to find where there it is, the counter.wasm file. However, this counter.wasm file, especially if it's a more complex contract, may be too big. The stock counter is probably half the maximum size. But if you've edited it, if you've added a lot of things, if you're including libraries and so on, it might be sizable. And we want to reduce it as much as possible. For this purpose, there are CosmWasm optimizers. The reduced size of contract code will not only reduce the gas costs when the contract's deployed, but also make the fees lower for every single interaction. And there's tooling to help with this. And it's publicly released Docker containers that optimize smart contracts. That way anybody else can go and take your code and use the exact same container and verify that the code on chain was in fact produced from the code that you have in your GitHub repo or whatever. And the command to do this is rather long. You need to have Docker desktop installed or some kind of Docker install, since you'll have to be using Docker. In order to do this, in order to run the optimizer, just run this command. And it should be in your history or somewhere easily accessible. You could alias it if you want with whatever the Rust optimizer version you're using is. For other chains, you might need to use special other kinds of optimizers. But this works for most CosmWasm chains. But this Rust optimizer will take the code that you have and optimize it down. I do need to authenticate. Docker's not running. So I open Docker here. It takes a second to start up. Okay, and now I can run the command and it will first, if I've never used this image, it'll download it and it'll optimize my contract and we'll see what that gets us. Uh-oh, killed. All right, we'll have to try this again. Okay, so I did successfully pull the image, but then something happened. So I'm gonna try it again here. And since the image already exists, shouldn't have to do it again. If you do run into a problem, then you, during that command, you can't actually kill it from the terminal. So you have to come in here and into your Docker desktop and do it there. I'm gonna go ahead and stop and trash this because it was running into some kind of issue. So here we go again. I think I have time for one of these. Oh, Dominion's organized now. Thing is, it's not going to be done yet. All right, it's done. 7 months and 37 seconds. That's not too bad. All right, so what we did was we downloaded the optimizer, and in that Docker container, this verifiable Docker container, we optimized it. And now in artifacts, we have our counter.wasm file. Can't display it. I mean, if you do display it, it's going to look like this stuff. And you recognize some of the items in here, maybe. but otherwise it's gibberish. There are WASM decoders, but this is bytecode. In the next video, we're going to take this code that we've built and compiled. Now that we have our setup all good to go and we have that account that can deploy the code, we'll actually push it to chain and we'll start testing it and making sure it works as intended.